Imagine a planet that could be better than Earth. A place with perfect temperatures, maybe even oceans, where life could thrive. Could humans one day move there? Could this be the next home for our species? For over a decade, NASA's Kepler space telescope has been searching for these worlds, peering deep into our galaxy, studying hundreds of thousands of stars. It's been hunting for planets, some similar to Earth, some larger, some smaller, but all with the tantalizing possibility of being habitable. Stories, headlines, and videos often claim that Kepler has found planets better than Earth itself. But what does that really mean? Are we talking about size, orbit, temperature, or something far more extraordinary? And most importantly, is it actually true? By the end of this video, you'll know the truth behind thousands of so-called Earth-like planets floating in space. You'll discover which discoveries are real, which are hype, and why being Earth-like doesn't automatically mean a planet is better than our home. Kepler's discoveries are incredible, no doubt about it. Thousands of new worlds, some eerily similar to our own, have been found. Yet, there's a gap between what science has actually confirmed and what sensational headlines want you to believe. So, buckle up. Together, we're about to journey across the galaxy, uncover the facts behind Kepler's most fascinating discoveries, and separate science from clickbait. By the time this video ends, you'll see the universe and our place in it in a whole new light. What is the Kepler telescope? Launched in March 2009, NASA's Kepler Space Telescope embarked on a mission that would change our understanding of the universe. Its primary goal was ambitious yet simple: find planets orbiting other stars, worlds outside our solar system, also known as exoplanets. For almost a decade, Kepler stared into the depths of space, capturing precise light measurements from over 150,000 stars, searching for the faintest hints that a planet might be passing in front of them. The mission officially ended in 2018, but its discoveries continue to reshape astronomy today. Kepler used a technique called the transit method to detect planets. This method might sound technical, but it's actually quite elegant. Essentially, the telescope watched stars for tiny dips in brightness, the kind of subtle flicker that happens when a planet crosses in front of a star from Kepler's viewpoint. To put it in perspective, it's like noticing a firefly passing in front of a lighthouse beam from millions of miles away. These brief, dimming events, measured repeatedly over months and years, were enough for astronomers to infer the presence of a planet and calculate its size and orbit. The scale of Kepler's observations is almost unimaginable. Watching over 150,000 stars simultaneously, it wasn't just looking for one or two planets, it was surveying a massive sample of the galaxy, searching for worlds both smaller than Earth and much larger than Neptune. Imagine trying to spot a tiny coin passing in front of a car's headlights from several miles away, and doing that consistently, night after night, for years. That's the level of precision and patience Kepler required, and it's what made the mission so groundbreaking. One of the quirkiest and most fun aspects of exoplanet hunting with Kepler was how counterintuitive it could feel. Astronomers were often searching for things that were technically invisible to the naked eye, relying entirely on patterns in light. For instance, spotting a planet required observing repeated transits over days, months, or even years. Sometimes Kepler detected systems with multiple planets, all creating overlapping dimming events, which made the analysis feel almost like untangling a cosmic rhythm. Kepler's legacy is not just in the planets it discovered, but in how it changed our perspective. Before Kepler, the idea that other stars were likely to have planets was mostly theoretical. Kepler turned that theory into a vast catalogue of thousands of candidate planets, confirming that planetary systems are common in our galaxy. Its observations laid the foundation for future missions like TESS and the James Webb Space Telescope, which continue the search for habitable worlds. Kepler's major discoveries. Kepler's mission transformed our understanding of the universe by uncovering thousands of planet candidates beyond our solar system. Out of these, several thousand have been confirmed as real exoplanets, ranging from tiny rocky worlds smaller than Earth to massive gas giants larger than Neptune. This monumental achievement revealed that planets are far more common in our galaxy than previously imagined, reshaping our ideas about how planetary systems form and evolve. Among these discoveries, Kepler identified planets that are Earth-sized or slightly larger, often referred to as super-Earths. Some of these planets orbit within the so-called habitable zone of their stars, where temperatures might allow liquid water to exist. The concept of a habitable zone captured the imagination of scientists and the public alike, fueling speculation about the potential for life beyond Earth. By studying planets in these zones, Kepler gave us our first glimpse of worlds that could, at least in theory, support conditions similar to our own. One of the most exciting discoveries is Kepler 1649c. This planet is remarkably similar to Earth in size and receives a comparable amount of starlight from its host star. Its discovery sparked widespread attention because it represents one of the closest matches to Earth ever found. Yet, while the planet is Earth-sized, scientists caution that factors such as its star's activity and atmospheric conditions remain unknown, making its habitability uncertain. Another landmark find is Kepler 186f, which holds the distinction of being the first Earth-sized planet discovered in the habitable zone of another star. Its orbit and size made it a milestone in the search for potentially habitable exoplanets, proving that rocky, Earth-sized worlds exist beyond our solar system. Kepler 186f's discovery opened the door to countless studies and inspired a new era of exoplanet research. Kepler also revealed super-Earths such as Kepler 438b and Kepler 442b. These planets are larger than Earth but smaller than Neptune, and they reside in their star's habitable zones. Scientists study these super-Earths to understand how planetary mass, composition and orbit might influence their potential to support life. Although we cannot confirm if they are truly habitable, they represent important stepping stones in the search for life beyond Earth. Finally, Kepler 62e and Kepler 62f are fascinating examples of multiple planets existing within a habitable zone. These super-Earths orbit the same star, demonstrating that planetary systems can be complex and potentially supportive of multiple worlds with Earth-like conditions. Their discovery highlights the diversity of planetary systems and fuels the imagination. Could any of these planets host life, or even be new Earths? Kepler's discoveries not only revealed the sheer number and diversity of planets in our galaxy, but also opened a window into the tantalizing possibility of finding worlds that resemble our own. Every confirmed planet pushes the boundaries of what we know and invites us to ask the big questions. Could life exist elsewhere? And what might these alien worlds look like? These discoveries remind us that the universe is far richer and more varied than we ever imagined. Better than Earth. When the headlines scream that Kepler has discovered planets better than Earth, it's tempting to believe we've finally found a cosmic paradise waiting for humanity. But the reality is far more nuanced. Just because a planet is similar in size or orbits in its star's habitable zone does not mean it is safer, more livable, or in any way superior to our home. Scientists are careful to separate what data truly shows from what makes an attention-grabbing headline. One key reason these planets aren't necessarily Earth-like is the type of star they orbit. Many of the so-called habitable zone planets discovered by Kepler circle red dwarf stars, which are smaller and cooler than the Sun. Red dwarfs, however, are notorious for violent stellar flares and radiation bursts that can strip away a planet's atmosphere and make conditions extremely hostile for life. Being in the right zone around such a star doesn't guarantee that a planet is actually hospitable. Orbit alone also isn't enough to determine habitability. A planet might be the perfect distance from its star for liquid water, yet still lack the conditions necessary for life. Without knowledge of its atmosphere, magnetic field, or geological activity, scientists cannot conclude whether life could survive there. Factors such as greenhouse gases, surface pressure, and tidal heating all play critical roles that Kepler could not measure directly. Another major unknown is the presence of water, oxygen, and other life-supporting elements. Kepler's instruments could determine planet size and orbital period, but detecting an atmosphere or surface water requires follow-up observations with other telescopes, such as Hubble or the James Webb Space Telescope. Until those measurements are made, any claims about life or Earth-like environments remain speculative. Media exaggeration has amplified the misconceptions about these planets. Clickbait titles and sensationalized videos often imply that humans could move to a new Earth tomorrow, creating hype that outpaces science. While these headlines draw attention, they oversimplify complex astronomical data and can mislead the public about what is truly known. It helps to imagine the situation with a bit of humor. Sorry, interstellar real estate agents, the universe doesn't have luxury Earth-like condos ready to move into yet. Every discovery is a step forward, but the real excitement lies in understanding the planets as they actually are, not how we hope them to be. Science is about curiosity and evidence, not wishful thinking. In reality, the planets Kepler found are fascinating and diverse, but none have been confirmed to have atmospheres, water, or conditions suitable for life as we know it. Earth remains unique in the solar system, and no exoplanet can yet claim to be better. The true legacy of Kepler is not in finding a superior Earth, but in opening our eyes to the staggering variety of worlds that exist in the galaxy and inspiring future exploration. The takeaway is clear. Earth-like in size or orbit is not the same as Earth-like in habitability. Scientists continue to study these planets with caution and rigor, using every observation to refine our understanding. So, while the universe is full of incredible worlds, for now, Earth remains our unrivaled home. By separating science from sensationalism, we can appreciate the true wonder of Kepler's discoveries without being misled. How scientists measure habitability. When scientists talk about a planet being potentially habitable, they aren't just referring to its size or distance from its star. The first concept to understand is the habitable zone. This is the region around a star where temperatures could allow liquid water to exist on a planet's surface, often called the Goldilocks zone, because conditions aren't too hot and aren't too cold. Being in this zone is an important factor, but it's only one piece of a much larger puzzle. The type of star a planet orbits is crucial. Different stars emit different levels of radiation and have varying lifespans. For example, red dwarf stars are smaller and cooler than the Sun, but can unleash violent flares that could strip a planet of its atmosphere. Larger stars may have more stable conditions but live much shorter lives, possibly too brief for life to develop. Understanding a star's characteristics helps scientists assess whether a planet could maintain a stable, life-friendly environment. Planetary factors also play a key role. Mass and gravity affect a planet's ability to hold onto an atmosphere, regulate temperature, and maintain liquid water. Too small, and a planet may lose its atmosphere. Too large, and it could become a gas giant with crushing pressures and no solid surface. The presence of a magnetic field can protect the atmosphere from stellar winds, and orbital stability ensures that the planet isn't subjected to extreme temperature swings caused by eccentric or chaotic orbits. Atmosphere and climate are equally critical. A planet in the habitable zone could still be unlivable without an atmosphere that regulates temperature and shields against harmful radiation. Even small changes in greenhouse gases or cloud coverage can drastically alter surface conditions. Essentially, knowing the orbit and size of a planet is like judging a house only by its size and location without checking plumbing or electricity. You need the full picture to understand habitability. Comparisons help put this into perspective. Earth sits comfortably in the Sun's habitable zone, with a stable atmosphere, magnetic field, and moderate climate. Venus, though similar in size, has a runaway greenhouse effect, boiling oceans into clouds of sulfuric acid. Mars, smaller and with a weak magnetic field, struggles to hold a thick atmosphere, leaving it cold and dry. Even planets like Kepler 1649c, which is Earth-sized and in the habitable zone of its star, may face challenges from stellar radiation or atmospheric conditions we cannot yet detect. In short, assessing habitability is a complex science that goes far beyond size and orbit. Scientists consider a combination of factors, from stellar activity to planetary composition and atmospheric conditions, to determine whether a world could theoretically support life. While the search continues, understanding these elements helps us appreciate why Earth remains uniquely suited for life as we know it. Most interesting Kepler planets. Among the thousands of planets Kepler discovered, a few stand out as particularly fascinating. One of the most talked about is Kepler 1649c. This planet is remarkably similar in size to Earth and receives almost the same amount of starlight as our planet. Located about 300 light-years away, Kepler 1649c orbits a red dwarf star, which means it may be exposed to stellar flares that could make life challenging. But here's the twist. What we see isn't the full story. While it shares Earth's size and estimated temperature, we still don't know if it has an atmosphere, water, or any conditions that could support life. Another historically significant find is Kepler 186f. This was the first Earth-sized planet discovered in the habitable zone of another star, a milestone that proved rocky, potentially life-friendly planets exist beyond our solar system. Kepler 186f orbits a red dwarf roughly 500 light-years from Earth and completes a full orbit. Scientists emphasize that while its discovery was groundbreaking, the planet's actual habitability remains uncertain due to unknown atmospheric and surface conditions. Kepler also uncovered several super-Earths with intriguing potential, including Kepler 438b and Kepler 442b. Both of these planets are larger than Earth but smaller than Neptune and orbit in their star's habitable zones. Kepler 438b lies approximately 640 light-years away and completes an orbit every 35 days, while Kepler 442b is around 100 to 200 light-years distant with a 112-day orbit. Scientists are excited about these planets because their size could allow them to retain atmospheres, yet their star's activity could make conditions harsh. Then there are Kepler 62e and Kepler 62f, part of a system with multiple planets in the habitable zone, located roughly 200 light-years from Earth. Kepler 62e orbits its star every 122 days, while Kepler 62f takes 267 days to complete a full orbit. Both are super-Earths, larger than our planet, and their existence in the same system highlights the diversity of planetary arrangements in the galaxy. While these worlds are exciting candidates for study, their actual conditions remain unknown, and they could be far less hospitable than their size and orbit suggest. What makes these planets truly compelling is the combination of similarity and mystery. They resemble Earth in certain ways: size, orbit, estimated temperature, but every single one comes with significant unknowns. We cannot yet confirm atmospheres, oceans, or other key conditions necessary for life. This tension between similarity and uncertainty is what keeps astronomers and enthusiasts alike fascinated by Kepler's discoveries. It reminds us that each planet is a puzzle waiting to be solved, not a ready-made Earth substitute. Kepler's most interesting planets spark our imagination, fuel scientific curiosity, and expand the boundaries of what we know about the galaxy. They remind us that the universe is full of strange, beautiful, and potentially life-friendly worlds. Yet we must approach each discovery with both excitement and caution. By studying these planets, scientists are gradually piecing together the vast cosmic tapestry of planetary diversity, keeping alive the dream of someday understanding what it truly means to find a second Earth. Exoplanets and our place in the universe. Kepler's discoveries have completely transformed our view of the galaxy. To date, thousands of exoplanets have been confirmed, yet only a small fraction are Earth-sized and potentially in habitable zones. While none have been confirmed to host life, the sheer number and diversity of these worlds show that planets are far from rare in the universe. This realization alone reshapes how we think about our place in the cosmos. The range of planets Kepler has found is astonishing. From massive gas giants larger than Jupiter to tiny rocky worlds smaller than Earth, the variety is immense. Kepler revealed that planetary systems are common and can be incredibly diverse, sometimes containing multiple planets in compact orbits around their stars. These discoveries challenge our understanding of planetary formation and highlight the endless variety of worlds that exist beyond our solar system. Kepler's legacy goes beyond just cataloguing planets. It fundamentally changed how astronomers approach the search for life and habitability. Scientists now know that rocky planets in habitable zones are not rare anomalies, but rather expected outcomes of planetary formation. This knowledge guides future missions, helping researchers target the most promising systems for detailed study. Looking ahead, missions like TESS, the James Webb Space Telescope, and Plato are building on Kepler's foundation. These observatories aim to study exoplanet atmospheres, detect biosignatures, and find planets even closer to Earth-like conditions. Kepler didn't find a new Earth, but it opened our eyes to the possibility that countless worlds await discovery, some of which may one day reveal signs of life or conditions remarkably similar to our own. The discoveries made by Kepler inspire awe and curiosity. They remind us that the universe is vast, full of surprises, and still largely unexplored. While we have yet to find a second Earth, the mission demonstrated that our galaxy is teeming with possibilities. Every dot of light in the night sky could be a world waiting to surprise us, each with its own story and mysteries to uncover. Kepler showed humanity that planets are everywhere and that we are just beginning to understand the complexity and richness of the galaxy. Its discoveries provide not just data, but inspiration, reminding us to look up, imagine, and continue exploring. The search for new worlds is far from over, and each discovery brings us one step closer to understanding our place in the cosmos. Myth versus fact. It's time to separate fact from fiction. A common myth that continues to circulate online is that Kepler discovered planets better than Earth. This claim is not supported by science. While some exoplanets share similarities with Earth in size or orbit within their star's habitable zone, there is no evidence that any of them are more habitable, safer, or more life-friendly than our planet. The fact is, Kepler discovered thousands of planets, and many of them have Earth-like properties, such as size and estimated temperature. Planets like Kepler 1649c, Kepler 186f, and Kepler 62e/FF show that rocky worlds in habitable zones exist beyond our solar system. These discoveries are scientifically significant and exciting, but they do not mean these planets are ready for human colonization or that they surpass Earth in any way. There are still critical unknowns. We do not yet know if any of these planets have atmospheres, water, or conditions suitable for life. Factors such as stellar activity, magnetic fields, and surface composition all play crucial roles in habitability, and Kepler could not measure them directly. Until follow-up observations are conducted, any claims about Earth-like conditions beyond size and orbit remain speculative. In short, Kepler's discoveries are extraordinary, expanding our understanding of planetary diversity and the prevalence of worlds in the galaxy. But the sensational headlines suggesting better than Earth are misleading. Kepler's discoveries are mind-blowing, just not in the way clickbait says. Future of exoplanet exploration. Kepler opened the door to a new era of exoplanet discovery, but it is far from the final chapter. Successor missions are now taking the baton, each equipped with technology designed to explore distant worlds in unprecedented detail. The Transiting Exoplanet Survey Satellite, or TESS, launched in 2018, is surveying nearly the entire sky, focusing on closer, brighter stars. Unlike Kepler, which looked at a small patch of the galaxy, TESS aims to find planets that are easier to follow up with detailed observations, bringing potentially habitable worlds within our reach. The James Webb Space Telescope, launched in 2021, is pushing the limits even further. With its powerful instruments, JWST can analyze the atmospheres of exoplanets, detect the presence of water, and even look for chemical signs that could indicate life. This marks a huge leap from Kepler, which primarily measured size and orbital data. By combining discoveries from Kepler and TESS with Webb's capabilities, astronomers are beginning to answer questions that were once purely speculative. Looking ahead, the European Space Agency's Plato mission, set to launch in the late 2020s, will focus on finding Earth-sized planets around Sun-like stars and studying their ages and compositions. These missions together represent a coordinated effort to identify worlds that could potentially support life and to understand planetary systems as a whole. Citizen science also plays a growing role in this exploration. Platforms like Planet Hunters allow anyone with an internet connection to examine Kepler and TESS data for potential new planets. This participatory approach means that curious minds around the world can directly contribute to discoveries, helping to expand our knowledge of the galaxy. As technology advances, the search for habitable worlds will continue to accelerate. We are entering an era where atmospheres, water, and maybe even signs of life may be detectable beyond our solar system. Humanity's cosmic adventure has only just begun. So tonight, when you look up at the stars, remember, some of those distant points of light could be hiding Earth-like worlds, waiting for us to find them.